Okay, problem 833 says water is flowing in fully developed conditions through a 3 centimeter diameter smooth tube with a mass flow rate of 0.02 kilograms per second at 15 degrees C. Determine A, the maximum velocity of the flow in the tube, and B, the pressure gradient for the flow. Okay, so let's jot down all of our givens. So we have water flow, okay, and we're told that it's fully developed. That's good. I have a diameter, 0.03 meters. I have a mass flow rate, 0.02 kilograms a second. I have a temperature of that fluid, 15 degrees C, and I'm asked to find what is the maximum velocity, Vmax, and what is the pressure gradient, dP dx. Okay, that's going to be a question. All right, so we have water. It's at 15 degrees C. I can look up the properties of that. The density is 999.1 kilograms per meter cubed, and the viscosity 1.138 times 10 to the minus third kilograms per meter seconds. So I will need to calculate what my Reynolds number is. I'm going to have to try and determine whether I'm laminar or turbulent, and we do that through calculation of the Reynolds number. The Reynolds number is equal to rho times V times the diameter divided by the viscosity. So I need to determine what my average velocity is. This is the average velocity, of course. So I can figure that out through knowledge of the mass flow rate. The mass flow rate m dot is just rho times V average times the cross-sectional area. Okay, so V average, I can rewrite this as just the mass flow rate divided by the density times the cross-sectional area. So that's 0.02 divided by 999.1 times the area, pi over 4 times the diameter, 0.03 squared. This gives me an average velocity of 0.02832 meters per second. So now I know my velocity. I can calculate my Reynolds number, 999.1 times 0.02832 times the diameter, 0.03, all divided by 1.138 times 10 to the minus third. Gives me a Reynolds number of 745.9. Okay, this is less than 2100, which is the critical value for flow in a tube. Therefore, we have laminar flow. For laminar flow, there's a solution. It's Poiseuille flow, right? And the flow in the tube, a laminar flow in the tube, we know that it has this parabolic profile. Okay. And we know also that the maximum value occurs at the center line. This is going to be Vmax or Umax. That maximum value occurs at the center line, and it's just equal to twice what the average is. Okay, so this is the average value drawn in blue. It's half of what the maximum is. All right, so then I know Umax is equal to twice the average velocity. So that's 2 times 0.02832, and that is equal to 0.0566 meters per second. All right, so that is my maximum velocity. That's part A. Part B is what's the pressure gradient? Well, again, for this Poiseuille flow, we have Poiseuille's law, and that says that the volumetric flow rate is equal to pi times r to the 4 divided by 8 times mu times the pressure gradient, which is always negative, so we put a negative to make it positive, dP dx. Okay? So now I can rearrange this for what dP dx is equal to. Well, dP dx is just going to equal minus volumetric flow rate times 8 times mu divided by pi times r to the 4. Okay, so volumetric flow rate, that's just V average times the cross-sectional area. Okay, so now I can start to calculate everything. V average 0.02832. My cross-sectional area, pi over 4 times the diameter, 0.03 squared, times 8 times mu, 1.138 times 10 to the minus third, all divided by pi times the radius, 0.015 raised to the 4. And that gives me my pressure gradient. It happens to be a negative 1.15 pascals per meter.